So we're going to look at differentiating e to the x, and we're going to do it from first principles. So we're going to use this graph, y equals e to the x, and we're going to try and find the gradient at this point here, 0, 1. And we know that if we start off with a chord, and then we reduce the chord down, and we slide this point here down towards 0, 1, then it will become get closer and closer to the tangent. So we've got 2 points. We've got the point 0, 1, and we've got another point up here, and the coordinates at that point are h, e to the h, where h is a small value. And we're going to look at the gradient, so we'll draw in the change in y over the change in x. And you can see that the change in y is going to be the y coordinates. So e to the h, take away 1, and the difference in x is going to be h. So the gradient of the chord is the change in y over the change in x, which is e to the h minus 1 over h. And we know that as h tends to 0, then the gradient of the chord tends to the gradient of the tangent, and we want that tangent to be at the point 0, 1. Now we know that the gradient of the graph y equals e to the x at the point 0, 1 is actually 1, and that was on the worksheet that I sent you today, on Tuesday, so that you could then look at the graph y equals e to the x, and one of the properties of that graph is it has a gradient at 0, 1 of 1. So we know that as h tends to 0, then e to the h minus 1 all over h must tend to 1, because that is the gradient of the chord. As h gets smaller and smaller and smaller, so that chord will become the tangent, or get close to the tangent at the point 0, 1, and the gradient of that tangent is 1. Okay, so we're now going to move across, and we're going to look at a more general term. So we've now got a chord AB. We're going to have that the coordinates at A are x, e to the x, and that the coordinate at B are x plus h, e to the x plus h. Again, we're going to consider trying to find the gradient at A. We're going to consider the chord AB, and we're going to find the gradient of that chord, and then consider what happens to the gradient of that chord as h gets smaller and smaller. So we're going to find the gradient by doing the change in y over the change in x. So the gradient of the chord AB is equal to the change in y, which is e to the x plus h minus e to the x, and that's over the change in x, which is x plus h minus x. We can factorize out at the top. We can take e to the x out, and we are left with e to the h minus 1, and the denominator is going to just simplify to h. And I can rewrite this as e to the x times e to the h minus 1 all over h. Now, as h tends to 0, the gradient of the chord is going to tend towards the gradient of the tangent at A. And so if we want to find the gradient at A, we can say that as h tends to 0, e to the x times e to the h minus 1 over h is going to tend to, now we already know from the previous page that as h tends to 0, this part here tends to 1. And so this whole expression is going to tend to e to the x times 1, which is e to the x. So the differential of e to the x is e to the x. And our conclusion is the gradient function of y equals e to the x is dy by dx equals e to the x.